I'm a graduate student of Chiba University, Japan. The title of my presentation is Detection of the Flooded Area by Tsunami using Satellite Thermal Infrared Images. First, I talk about background and objective. Heavy casualties and severe property losses occurred by the tsunami in the Tohoku earthquake occurred on March 11, 2011. Information networks were suspended, thus grasping conditions of disaster areas were very difficult. Satellite remote sensing is widely used to grasp the tsunami disaster. However, many satellite images cannot be used during nighttime. Thus, blank time may occur. However, satellite thermal infrared images can be used during daytime and nighttime without depending on sunlight, and hence it is possible to eliminate the blank time. Although the spatial resolution of satellite thermal infrared images are inferior to aerial thermal infrared images, it is possible to grasp large-scale disaster like massive inundation by tsunami. In this study, the estimation of flooded area was carried out by superimposing temporal astro-thermal infrared images captured before and after the Tohoku earthquake and aims to quickly grasp the tsunami disaster. 2011 Tohoku earthquake. This table is a detail of tsunami disaster. A large number of aftershock followed main shock and a high probability of new great earthquakes. Rapid countermeasures for earthquakes and responses to disasters are strongly desired. This is detail of tsunami disaster. These photographs are taken around Ishinomaki City by field survey. Right figure is one of the inundated area map that was created by Geospatial Information Authority of Japan, alias GSI. It shows Fukushima and Miyagi Prefecture. Red area is inundated area. As a study area, Ishinomaki and Soma City were selected, where serious damage was observed by tsunami. This is flowchart in this study. First, prepare astro-thermal infrared images before and after the Tohoku earthquake and assign other colors. Color composite those images and estimate the flooded areas. Compare the estimation result with astro-force color images in same period and inundated area map that was created by GSI. And finally, accuracy assessment. And this is analysis data. To eliminate the seasonal variation in temperature as much as possible, pre and post event images were taken same season in different years were used. Upper figure is pre and post event astro-thermal infrared images in Ishinomaki City. These are taken daytime, therefore sea area is low temperature. Lower figure is taken Soma City, Fukushima Prefecture. These are nighttime images, therefore sea area is high temperature. First, estimate the flooded areas by using Ishinomaki images. Left figure is pre-event astro-thermal infrared images taken 2 years before the earthquake. Right figure is post-event image taken a month after the earthquake. Each image are taken taken in daytime, and each maximum air temperature was very close condition. Assign the other color for each image. Pre-event image is assigned cyan, and post-event image is assigned red. And this is color composite of those images. In this figure, red area is increase of temperature area. Cyan is decrease of temperature area. This figure taken daytime, so therefore, estimates the decrease of temperature areas were flooded. This figure has large two decrease of temperature areas. First, area 1 to examine. Left figure is enlarged place of area 1. Right upper figure is easy extraction result of estimated flooded areas. Lower figures are pre and post event as the false color images taken same period. This place has many paddy fields, and in this place, tsunami ran up along the Sada River and caused heavy damages in inland area away from the coastline. And many areas had still lower temperature than before, compared to that before the tsunami, although it was a month after. And next, this is enlarged place of area 2. This place is estuary of Kitakami River. Similar to area 1, tsunami ran up along the Kitakami River and caused extensive damages. Look at the post-event false color image. The land near the estuary was washed away by the tsunami, became seawater area, and many areas have still flooded by seawater. It confirmed that the estimated flooded areas and false color images were relatively in good agreement. Next, discuss about Soma City. Left figure is pre-event image taken 3 years before the earthquake. Right figure is post-event image taken the next day of the earthquake. Each image were taken night time, and each maximum air temperature was approximately equal condition. The same way as Ishinomaki case, assigned cyan and red for each image. And this is color composite image. The water has large heat capacity, and this is in case of nighttime. Therefore, sea areas estimates the increase of temperature areas are flooded. Focus for this coastal area. This is enlarged place of coastal area. Right to figure is pre and post event as the false color images taken daytime with similar condition as thermal infrared images. Look at the post-event false color image. The paddy field, the shape of lagoon and paddy fields have changed significantly. Compare with estimated flooded areas are relatively in good agreement. Therefore, in case of nighttime, to glass the flooded areas by thermal infrared images were very effective. However, thermal infrared images are affected by air temperature, weathers, and seasons. Therefore, require the discussion in various situations. This is estimation result with compare estimation result with inundated area map. Left is Ishinomaki image, right is Soma image. This figure shows easily extraction result which were only large temperature difference areas and superimposed on inundated area map. Estimated flooded areas in Ishinomaki is blue area, Soma is green area. It confirmed that the estimated flooded areas are inside of red areas. Therefore, two glass flooded areas by astro-thermal infrared images were very effective. Conclusions. In this study, astro-thermal infrared images were used to grasp the tsunami disaster by the Tohoku earthquake occurred on March 11, 2011. The pre- and post-event images were assigned by cyan and red colors, respectively, to estimate the flooded areas by color composite of those. In daytime images, the estimated flooded areas shows a decrease of temperature. In nighttime images, those shows an increase of temperature. Comparing the estimated flooded areas by astro-false color images to inundated area map by GSI, it confirmed that those are relatively in good agreement. It is sufficient to grasp flooded areas. In future, consider the extraction parameters. A quantitative extraction method must be developed. Thermal infrared images are affected by air temperature, weather, season, and clouds. Therefore, may be difficult to provide those by the same condition. If thermal infrared images are not enough available, it will be considered to create a method that use GIS data as prevent images. Discussion is required for the temperature properties and their accuracy to build an early detection method of future tsunami disaster. Thank you for your attention.
Anyone has a question or comment? I have a question, a simple question. How do you validate your result? How do you validate the result? You compare with the satellite image or use surveying data to validate your result. How to check your result is correct, your immunodate area is correct.
Sorry, one more please.
Could you move slide to the immunodate area? Immunodate area.
Yes.
I just mentioned, did you check this result? How to check that? Yeah, we can discuss later. Yeah, thank you for your presentation. Yeah.